Perfect. So hi everyone again. My name is Catherine. I'm a member of the AGU Early Career Committee for the Atmospheric Sciences section. And today we are so excited to have Gavin, John, and Michelle join us in this webinar on careers in government. I'll let them give a quick bio of what their roles are now, where they work, and then just a little bit about themselves, prior experience, what their research focuses on. So yeah, let's give everyone a big round of applause, and we can start with John.
Okay, thanks. I am John Sullivan. I currently work at NASA Goddard Space Flight Center in Greenbelt, Maryland. I'm an atmospheric chemistry and dynamicist. I'm actually on a detail to NASA headquarters right now. So this is a part-time detail where I'm taking on some additional responsibilities. My focus is largely in atmospheric composition, specifically using laser-based technologies and remote sensing to probe the atmosphere in the troposphere and stratosphere. So trained scientist, but have been wearing a more program management hat as well for the last 6 months or so. So happy to be here and answer some questions. Thanks.
Great. We can go to Michelle.
Hello, hi everyone. My name is Michelle Huang. I am an air quality specialist in the Air Quality Sensor Performance Evaluation Center, back at South Coast Air Quality Management District. So I got my PhD in atmospheric chemistry from UCLA, and after that, I joined AQMD after I graduated. So this is actually my first job. I'm still here with AQMD. I first joined AQMD as an air quality instrument specialist, and then later got promoted into air quality specialist in AQSpec. So our group does the performance evaluation of commercially available air quality sensors. I'm primarily in charge of the laboratory evaluation of these sensors in our environmental chamber. I also do data analysis, write reports, and sometimes we do have to write manuscripts and stuff. So I'm happy to be here today. Thank you.
Thank you. And then last but not least, Gavin.
Hi, my name is Gavin Cornwell. I'm a research scientist here at Pacific Northwest National Laboratory. I got my bachelor's in chemistry from UT Dallas, and then I took 6 years off before going back to school at UCSD, where I did my PhD with Kim Prather, where I worked on marine aerosol and aerosol cloud interactions. Then I joined PNL in 2019, where I did my postdoc with Susanna Burrows before converting to staff in, in 2022, where I worked on ice nucleating particles. Then in 2024, I got an early career award to study biological ice nucleating particles, and that's what I've been working on for the last year or so.
Great. All right. So before we start, I did just want to say that please feel free to send a question in the chat. We will be screening questions and we'll pass them along to our panelists and to myself, provided we have time. So thank you all for joining. And one of the first questions that we kind of ask in these webinars, and I think it's a good one just because it gives a good idea of, what you all are doing, but what does a normal day look like for you? Are you in the lab? Are you writing grants, proposals? And I don't know if someone has a strong desire to go first. But yeah, I'll open that up to the panelists.
Yeah, I can kick off here, just going with the same order we went in. So I mentioned a lot of our work is instrumentation on the science side. So largely a lot of the federal labs, they will propose to do some large scale field project. And really what those field projects do, they'll target generally a few specific science topics. I'll take, for instance, the Discover AQ campaign might be a good example of a historical campaign where you had multiple NASA centers, multiple NOAA centers, and some other coordinating federal labs, EPA, for example. And so there is this critical mass going to the field project. So a lot of the federal lab work is basically preparing instrumentation to get out to the field. You're, generally doing lab testing, things like that, on a variety of different instrumentation. A lot of federal labs, they have core capabilities that might be with surface networks or airborne facilities. I know NASA, one of the highlights of working at NASA that I found is really working with some of the suborbital airborne communities. So putting things on aircraft and flying them around. And like I said, largely in concert with NOAA and sometimes NCAR facilities as well. And then connecting that to the larger science goals. So I think there is a fair amount of field work at a lot of federal labs if you're interested in that. There's also modeling capabilities as well as sort of pure data analysis and things like that capabilities. So I think largely if that is an area you're interested in, a federal lab would be a good resource. So I've already forgotten the question, so maybe I'll pass it over to Gavin to help me out.
Yeah. As far as a normal day, what that looks like for me is, I have roughly 3 to 4 projects that are going on at any given time, and I find that you can really only focus on 1 or 2 of those to any great degree. So it's, varies throughout the year. Like right now, we have a field campaign that we're prepping for. So I've been in the lab basically every day for the last month and a half or so, making sure that our instruments are prepped and that they're ready to go. But, my experience generally here has been that we do sort of large scale field experiments and then we analyze the data. And that's what most of our days look like, is analyzing data, writing reports. Yeah, that's what I would say.
And Michelle, do you want to give some insight into a normal day at AQMD, more on the local government side? I think you're muted. Uh-oh. Technical difficulties.
Claire, do you want to go ahead and try to make the panelists all co-hosts, and maybe that will help them with being able to unmute their mics?
Yep, I can do that.
Still can't hear you. It looks like you are still muted. But for the time being, I guess we can go into the next question and then circle back for a normal day. What did the hiring process look like for your position, or I guess when you were entering into where you are now? Or is it similar to other positions that you had?
I guess I'll kick us off here again. I think most young scientists in this field, I was able to earn a PhD in or higher advanced degree, master's or PhD in atmospheric physics, and then I went on to do a postdoctoral position. So a lot of that generally is you're continuing some of your PhD work. I think historically, I had advice on go do something completely different in your postdoc, and then come back and kind of have that complement your sort of technical expertise from your PhD. Maybe I'm a little bit different. I just continued on with what I was doing, which I really like the ground-based remote sensing aspects of what I do. I think it's really exciting and still an area of interest that can be sort of published. So I stayed in that area. And then I continued on from a postdoc to then actually, luckily enough, getting a federal position at NASA Goddard shortly after, and have been there since, continuing doing some of the same work. So I think my trajectory is a little bit more linear than a lot of folks, but kind of had some personal situations that I was just needed to kind of just stay where I was, and combination of family and other circumstances, it kind of was the right fit. So I think that's sometimes lost on a lot of people when they're trying to make these decisions. Is ultimately it's kind of what's the most important for you and sort of your inner circle, as to some of these decisions, and just take that as you're kind of thinking about your next stages as well.
I think the audio is maybe working for Michelle, so we can go back to normal day and then hiring process, I guess.
Okay, I'm so sorry. I think like Zoom froze for a little bit. I'm so sorry. I rejoined in, and I hope everything is okay right now.
Yes,
Okay.
great. Thank you so much.
I'm so sorry. Yeah, so for me, a normal day at work, it really depends on what I have to do. So our group tests air quality sensors for performance via field and laboratory tests, and I'm in charge of the laboratory evaluation of these sensors. So on a day that I have to do things involving the chamber, then I would basically spend my entire day in the lab doing either sensor testing or making sure the instruments are working well, and doing some method developments and experimental designs and more testing. Yeah, so I will be in the lab all day long. So on the days when I don't have to do those steps, lab testing, I'm mainly doing some data analysis, writing reports, and there are also lots of meetings and some administrative stuff that we have to take care of. And if we're writing a manuscript, then I will have to also spend some time doing literature reviews and stuff. So and we also do have a lot of projects, so it depends on what we're doing. But on the days where I have to do chamber testing, I'm basically in the lab all day long. And the next question is about hiring process. Okay. So for AQMD, typically there are 2 rounds of interviews, and 1 panel interview and 1 hiring interview. It depends on the position. Some positions like air quality instrument specialists and chemists, they actually require a test prior to all these interviews. And I think if you perform well enough on these tests, and then you will be advanced to the next step of the interview process. So, and these processes can take quite long sometimes, and can take a few months. But there are also a lot of internal transfer and promotion opportunities once you're in. So yeah, that's how, yep, and that's all I have.
Great. And then Gavin, if you wanted to share a little bit about the hiring process for you.
Yeah, so this may not be the most relatable, but I was hired also under another early career project to basically do another project, or to repeat a project that I had done in grad school, that just because of the instruments involved, almost nobody has experience with. So it was like basically written as well as possible for me. So I think I can maybe I've just hired a postdoc this year, so I could maybe talk about that process a little bit if that would be helpful for people.
Yeah, I think that would be great.
Yeah, so I got the award last year. I had to work with my team lead here, my manager, to write the ad, post the ad, screen the applicants, which took more time than I was expecting, and it was also harder to get the ad out to people who could see it and or who would be like, qualified. I found that the best route was going through people's professors, which may not be a surprise if you've been in science for a while, but that was the most effective way. And then it was uh, let's see, a phone screener with all the potential candidates, and then 3 virtual interviews with the people I had narrowed down after that. And yeah, the candidates also met with different people within the team to make sure that other people thought that they would be a good fit. DOE is a very collaborative and sort of team-focused department, I guess. So making sure that you play well with others is kind of pretty important. So yeah, I don't know if people have any other questions about that, but.
That was really great, and I guess very timely. So that was really wonderful that that just happened and happened for the panel. But I guess next question is kind of tied into audience questions as well as one that we had pre-prepared. Are there experiences in your early career or education that you feel would have better prepared you for a position? And specifically, if there's any advice for a graduate student with long-term ambitions of attaining a project management position? That's kind of geared more towards John, but it's open to everyone. Yeah.
Yeah, thanks for the question. I think that was Lucas. I think what has helped me, and this is probably not the answer people want to hear, but is basically, for the last decade, applying for research funding from a specific research program. This was within NASA, but all the federal labs have a similar, well, I should say, a lot of the state agencies as well have funding calls. So it was, I think, just through proposing for funds, successfully winning proposals, going out to the field and doing a lot of the measurements. Like I said, this was a very measurement heavy group. And then I think just by proxy of that, starting to learn what program management roles might be. But I think really the part that I felt started understanding the project management in some respect, and project management at NASA or another lab, really what I think about that is really how you write solicitations and run panels. So really the aspect of this that I would recommend, even if you're just starting out, if you're able to get on a review panel for a specific solicitation, it's really going to start flipping that switch in your brain as to what are the programmatic things that people are looking for. It's going to make you a better proposal writer. And I'm sure there are entire seminars, maybe AGU even has one on writing proposals, but just in the sense of once you get to your potentially kind of niche specific area, understanding what the major sources of funding are. When you're writing these proposals, a lot of time they're asking for a specific part of that funding area or that specific part of the science. So I think you just naturally over time develop a little bit better of an idea of what these project management positions might be. I will just say, from my perspective, sitting at headquarters a few days a week now at NASA, most of the people there were sort of successfully proposing PIs for a lot of years, and then they were in the trenches, for lack of a better word, in the trenches, and then they were kind of asked because they needed to fill a position. They kind of moved up to a program management perspective. So I think that's more the trend. I think even just hiring writ large at federal or a lot of facilities, it's you generally are there for some years or working with a specific group, and then you make the natural transition maybe to working in that organization or program management. So um, I'll see if Gavin or Shelby has anything to add.
If not, there is kind of a follow-up question with skills that candidates should have to set themselves up for hiring success. Also, in addition to that, it seems like we have a lot of people dealing with instrumentation here. So how do you kind of diversify yourself from just like being really tailored into one instrument or knowing one instrument? Do you have any advice for like growth in terms of getting more familiar with different kind of data techniques, analysis, et cetera?
Yeah, I mean, that's a question that I've never really stopped to think about, because I just a lot of times you are in a group with a specialized set of skills, and the reason, almost by definition, the reason you're still taking those measurements are because they're still important to the community, and they're still applicable for funding and research calls. So I think the question I would really ask is just, when you're thinking about those measurements, think in your head, if your goal is for science publication, or your goal is for research, or your goal is maybe to support some policy measurements, be thinking about what those measurements mean, and it takes a lot of years to once you start getting down in the data analysis framework, to think about additional measurements that you might want to be pulling in. So I think as long as you're flexible and understanding, you want to be usually striving for a science result, or striving for a policy outcome, or as long as you can kind of keep that as that's what you're aiming for, and the different measurement techniques are just tools to get you there, I think that's the right approach. It's don't put yourself in a specific box. Think about, are there other tools I could be using? And there are commercial ventures that are making a lot of equipment now that can be just as good as a lot of the research grade equipment. And so thinking about that, and if you might be able to use small sensors for your application, you might be able to use something non-traditional. But I don't think if you specialize in a single instrument, you are putting yourself into it's risky. I think if you are understanding the instrument, really all of the parts of the instrument, that's really what you want to be spending your time on. If you are learning the instrument, learn how it operates, learn the optics, learn the flow, the rate, the electronics. You don't have to be an engineer, but understand it all, be able to explain it to somebody, but then also understand what makes that a unique piece of hardware, right? What makes that unique, and answering maybe some broader question about science or research that we're interested in. So
yeah, I would just add that depending on the instrument that you're working with, being a specialist in that can actually be seen as quite positive. Especially if it's temperamental or difficult, or the analysis is complicated. I think that actually sets you apart quite a bit. So yeah, I just want to throw that out there. That's not necessarily a bad thing.
Yeah, I think I'm trying to add that it's that I second Gavin, that if you're specialized in something, it's actually really important and makes you standing out. That's for sure. And I also feel like we work with instruments a lot, and we know that they fail a lot. So I think like, it's really important, like, knowing like the way how to troubleshoot it, how the problem solving, it really applies to all of like other instruments. The process is the same. So I think those are very valuable experiences. And when you know the instruments inside out and you know how to troubleshoot it and fix it and stuff, I think it's very important.
Great. So then, is there anything you had wished you had learned along the way, maybe in grad school or like in your early career positions, that might have helped you now, or just
I'll say that if you're interested in working for DOE, which I think is a good institution to work for, that you should look at trying to get fellowships or experiences with the labs early. There's definitely opportunities for that. Like there's the SCG SCR, I think, fellowship, which you can apply to get experience with DOE scientists. There's RAU opportunities. We hire PhD interns, and I think there's definitely opportunities to reach out to DOE scientists that you might be interested in working with. We are busy, but we don't necessarily have the same number of people working for us as like university professors. The like immediate groups tend to be smaller, so I think there's like more opportunity than you think to reach out to people and try and get your foot in the door early.
Yeah, I also agree. Yeah, if there's one thing that I wish I have done back in grad school, maybe getting an internship somewhere, like, just to experience, get some insider knowledge on the company or the agency or for the field that you're interested in. So I think that would really diversify your experiences and could enhance both technical and soft skills. I think that's really important. Yeah.
great. I guess we can kind of shift to a different question in how do you secure funding for your position? There was an audience question about the percentage of your time that's spent, also just in terms of how you spend your time with the funding. Is it getting grants, or are you really just doing analysis and research? So I guess it's a two-part question. Maybe we start with Michelle.
Okay, so our program is funded by South Coast AKMD, so we don't like have to actively write grants or anything, but we do sometimes apply for grants for projects that can better serve our community. So we do apply for some, but that's like a side project. It's not like our main funding. Yeah.
Yeah, I'll just add, I think, so I'm working at NASA. There are, at least from NASA Goddard, there are civil servants, which are federal employees. There are cooperative scientists. So they generally are associated with the university that is able to work at NASA. And then there are contractors. And so I say that because most of the civil servant they're kind of strictly only able to get funds. I mean, there are a few exceptions, but most of their funds are from within NASA. So there's a annual solicitation for funds called Roses. I can put a link, or Maddie can put a link in there if anyone's interested. But this is sort of an omnibus of all of the NASA solicitations that are out. I mentioned the cooperative agreement scientists and contractors because they are very free to apply to all sorts of funding. So I have a group here that focuses on LiDAR instrumentation and remote sensing. I would say that we have some core funds from NASA to take measurements and continually take some of these, calibration measurements and calibration from a internal, using a lamp calibration or sort of a spectral calibration, but also once the satellites are launched, a sort of ground truthing calibration as well. Some core support for that. And then the other half is some of these ROSE's individual research and analysis type projects. So smaller pots of money, but they're able to then bring on postdocs or bring on additional research scientists and things like that. So most of those are 3 to 5 year awards. So we kind of go in cycles. Some of the core funding are in 5-year increments, and then the individual ROSES or RNA proposals are on 3 to 4 years. Some might be 2 years, but 3 to 4 years. So it sort of allows you to have a little bit of time to sort of, understand how you would really start the proposed research if selected, and then start putting together some papers and progress reports, and generally presenting on that at a conference like AGU is a great resource for that. I think in general, I think about less of a fraction of my day being spent thinking about the next proposal or funding, but rather there's just these really intense time periods throughout the year that it's sort of a sprint to get a proposal out the door, or someone is writing a proposal and they need support from our instruments or something like that. We've got to then sort of, unfortunately, sometimes drop everything we're doing to get them the documents or the text they need for their proposal, and then submit it. So and I think that's probably true for a lot of federal facilities, and frankly, anyone in the scientific world, in terms of federal facility, university, or state and local agencies as well.
Yeah.
I don't know if you wanted to go for it.
Yeah. So I actually haven't done that much proposal writing since I've been here. When I applied for my award, that was the first time I'd written a large one by myself. We have these smaller internal proposals for MSL user proposals, if you know what that is. And then also sort of like some internal lab money to like develop projects for future funding. But for the most part, most people in the atmospheric sciences sector here were supported under SFAs, or scientific focus areas. So these are like large multi-year grants that will support a large number of scientists for like a pretty significant portion of their time, like 50% of their time or something like that. And so mostly it's senior scientists writing those. You're expected to contribute to what you might want to do under that SFA, but you're not writing the full proposal by any stretch of the imagination. So it's not what I had expected it to be like when I came here. I thought it would be similar to a university professor and just writing grants a significant amount of the time, but that has not been my experience.
Great. So you all work in different labs, but what do you collaborate with other labs, interagency, intraagency, or other sectors, with academia? I think there's an interest in, if there is collaboration in your field or not.
Yeah, I think we're all collaborating. I would say in the largely, I just mentioned the proposal writing. That I think is probably the major way where we, if we're taking a measurement, or we're looking for a measurement, or we're looking for a team to do some data analysis that we think they would be great at, or there's some shared resources we'd like to look at. Really, the proposal writing process, you're thinking about that from a few different perspectives, and one of those is sort of formal collaboration. So when you're submitting those proposals, then you would have, a collaborator at a university or an agency, or vice versa. They could submit a proposal, and then you could be a collaborator on that. So those are formal collaborations. I feel there are certainly informal collaborations where if you are working on something or a field project, and there just might happen to be other resources there from another institution, you're likely going to coordinate with them and on measurement days, or in data analysis, or in sort of final field reporting and things like that. So yeah, I don't think you can really successfully do a lot of what we do without collaborating. And even when it comes down to publishing some of your work, I've always been a big proponent of adding as many collaborators as you can within reason, just to make sure you have other institutions acknowledged, because sometimes that institution might really value the fact that they had some credit on that manuscript or that piece of work, but also to forecast to your management chain that you are working with others, and you're not a sort of a single entity in the field. You're respected, and then the practical matter of just having sometimes more eyes on a paper makes the paper, I think, more impactful, and sometimes it can get you to a tighter conclusion. So.
Great. Don't know if Gavin or Michelle want to add on to that. If there's a lot of collaboration in your groups or within your lab, or.
Yeah, we do have some collaborations with like academic groups and stuff for the past projects, and on like community monitoring using error sensors. And we've also collaborated with like an agency or a company um, developed a test standard for ASTM. So those we do have like collaborations here and there, but mostly they're more independent work.
Yeah, I would also just add, we do collaborate, particularly within the lab and within DOE, but also with universities. And we also do a fair amount of work with other government agencies. Like I do some work with the NRC. We have some national security type work that we do. I don't know if you would strictly consider that collaboration or not, but it's kind of an important part of your work portfolio.
Great. To kind of follow on to that, and we can start with Gavin for this, how would you describe the culture of your agency and how the work and environment might differ from other agencies in the same field?
I'd say it's very mission-based. DOE tends to have a pretty clear idea about what it wants to do, and if your personal research interests are aligned with that, that's great. If not, it can be kind of tough. I think tends to also want to do sort of big science that it's hard to do at a university, just as sort of a practical matter. And it's also got a very strong safety culture, which I think can be frustrating for a lot of people when you come directly from university. So.
John, did you want to add on to that?
Sure. Yeah. I mean, definitely echo what Gavin just said. We are very mission oriented. I think which can be good, because a lot of times that is synonymous with sort of stable long-term funding if it's committed to a certain mission, especially some of these satellite programs that can often exceed a decade. Sometimes some of them are nearing 2 decades. So you can really sort of hitch your wagon. You could make a career out of supporting a satellite program or something like that. And I think that is important work that the federal labs, obviously in particular NASA, are very good at, and they're kind of one of the only ones that might be able to sort of have the in-house expertise both to do sort of the science ideation, sort of that incubation of the satellite idea, have sort of the engineering technical expertise to then sort of put an idea together and then sort of carry it out. And of course, a lot of that will be either coordinated with or sent to our private partners to help build and to potentially launch. But that is something, if you're interested in that, and in particular in the earth sciences, if there's only something that you think can really be done from seeing a global picture, it's a really a great place to work. We also have I think a safety culture here that does make some things challenging. And then the other thing I wanted to mention was, early on I started a project working on long-term records and long-term trends. And the care that goes into a lot of these, X% per decade or X degrees per decade trends, it's something you really want somebody to do that is going to be there for a long time. And it's hard. And I believe me, I'm sure NASA tried to do this. But if you're really looking at trend detection, it's hard to really get that level of quality if it's on a graduate student every few years, and you're changing hands and code is changing hands. And so I sort of looked at the federal lab as a also somebody that is sort of the curator and the holder of some of these long-term records, in terms of, that's true for satellites, that's true for ground-based measurements, and that's also true for a lot of airborne instrumentation that you can't really afford, if you really have an airborne measurement, something that you're going to put on a plane. It's a lot harder to have that at a university where that university PI or the graduate student there might come and go. If you really think that is a core measurement to support your mission, we've got to find a way to make sure that asset can stay at NASA and fund long term. So it does come with then some historically relatively stable funding, but it also allows you to to sort of continue to not just preserve that measurement, but have a chance to improve the measurement and still make meaningful contributions to your own area of research.
Awesome. Michelle, do you want to speak a little bit about the culture of AQMD?
Sure, yeah. So I have to also say that, AQMD is also very mission oriented with the goal to clean up the air and protect the health of all the residents living in the basin. So we are also very focused on data integrity. Just have to we try to do our best to make our data as defensible as possible. So besides that, I would also wanted to say my first impression of my company is that it feels very welcoming. Besides all the missions and stuff, now it's under the people. I think people are very important. People who are working with are very important. My first impression was that they're very welcoming. People are very nice. I learned a lot through training by the seniors. And management is usually very supportive and understanding. So they really care about the staff safety and their well-being, which is very important. Like John said, safety it's a very important thing. They make their efforts to make sure everyone's safe and happy. So yeah.
Great. Another question for all the panelists is, what motivated you to go into your specific government research center? Especially since it does seem like the motivations are kind of the same. And then, what would you say is the best path for to become a full-time scientist position once someone's finished with their PhD? Is that a postdoc, or are there positions already available?
Did you want to lead off, Gavin?
No, go for it.
See, um, I think as it's already been mentioned, there are, I think, a handful of postdoc opportunities. If you wanted to stay in the sciences, I don't know if a lot of the group here is more on the policy side or the engineering. That might not necessarily be the right approach, but I think from the sciences, there is sort of this apparatus of multiple postdoc programs or something akin to that at a lot of the federal labs. Some of those might be sort of externally broadcast. Some of those might be more internal hirings and things like that. But I would just say that just there are networks here. I know that there are a handful, and AG can probably do a better job than I can in terms of pointing you to the links and finding those out. But I think just thinking about what I've said throughout this, and in sort of keeping with that mantra of just a lot of people have joined these federal labs and they like the work, they continue to stay, and then when people know that they are reliable and they have the right personality and the right mentality really to work there, I think a lot of opportunities start to open up. So I haven't hired anyone very recently. Maybe Gavin can point on that, but I think that it's harder and harder to take a chance on an unknown quantity of somebody that you might potentially be working with for a decade. So really, a lot of the postdoc opportunity compared to maybe a traditional sense of it is advancing a skill set or something like that. It's almost a dress rehearsal for, are you the right fit for, and you want to find that out. You want to find out if you're the right fit for maybe that lab or that group just as much as they want to find out if you're the right fit. I would just encourage anyone to, if they're considering that, and it's good for both parties to understand that. And I think a lot of this is still very in the professional development realm, where if they do find that you might not be the best fit, a lot of times if they've been at that federal lab for a while, they might be able to laterally move you to another organization, another lab, maybe another better fit to make sure that you end up where you want to end up. So I'll pass it over to Gavin to finish my thoughts for me.
Yeah, I mean, I'm trying to think. I don't know of anybody, here at PNL who's a, scientist who didn't do a postdoc. So if you're looking to stay in research, or like if you want to, do sort of federal research, like I think that's something that you're going to have to do. I think I said this a little bit earlier, and just to reiterate what John just said, like it is really helpful for people to know you within the context of like how you work. The postdoc I hired, I probably would have hired him anyway, but he had worked with, a number of people that I worked with, and they all vouched for him. They said like very, they gave him a strong recommendation, and that was, tremendously helpful, because hiring is like a crapshoot. It's not a given that somebody is going to work out. It's not a given that you'll work out as a mentor for that person. I think the more information you have going into it on both sides is better. So yeah, I don't know if Michelle has anything else to add to that.
Yeah, I when I graduated, so I wanted to see like what's out there besides academia. So I started applying for jobs. And then after I joined AQMD, I think I joined as like one of the more entry level kind of job. But then once you're in it, there are like lots of opportunities. There are lots of like internal transfers and like promotions. So you kind of get to know what other groups are doing if those would interest you. So that's how you can keep applying for the group that you want to work for. And I stayed in my group after, and I got promoted to my group, and I stayed here for about 7 years now. And luckily, I'm still very happy with what I'm doing. So I'm very thankful for that.
Awesome. So this is an audience question. So even though many of the panelists work on instrumentation, can you touch on government careers in modeling or analyzing data? Maybe what opportunities might be available?
Yeah, I can say, at least if you're trying to work at P&L, it's much easier to get hired if you're a modeler compared to somebody who's doing instrumentation. It's a lot. You just have to look at our division, and it's honestly like 2 to 1 or 3 to 1. It's just the startup cost for it is so much less compared to buying instruments. Doing lab experiments, that is also difficult. Deploying to the field is even more expensive. It is just a lot easier to analyze data that's already been collected or to model it. So I wouldn't worry about that. It would be more about making sure that you stand out as a candidate if you want to keep doing it in the future.
Yeah, I'll just add to that, which is great advice, and I didn't quite realize that about PNNL. So good, I'm learning on here as well. Modeling is I think it's I think about it. Well, I don't think about it. It should also be said, a lot of labs or federal facilities think about modeling in different ways. So NOAA is an operational agency. So they are, no matter what, they need to have their forecasts out at a certain time, usually every 6 hours or sometimes every hourly. And that is mandated by, the government Department of Commerce down to NOAA. So the modeling there is largely, keeping operational forecasts and operational models working. So the modeling you're going to be doing there might be just that in that framework, right? It's you couldn't really do anything that would compromise a forecast getting out. If you're at NASA, we are not an operational agency when it comes to modeling. So I find there's a little bit more interest in people that gravitate towards maybe process level modeling or sensitivity studies or something that is not quite that core operational modeling aspect that you might have at NOAA. For EPA is another organization we work closely with. A lot of their modeling is for ultimately a lot of policy decisions. So they depending on some of the modeling runs they have, it might end up downstream resulting in some policy decisions. So I think that I would push you on whoever asked the question. I can't see the name, but to hit on Gavin's point, I don't think you're going to have a problem, but I think you from a personal perspective might want to start thinking about, do you see yourself as a modeler that might be this, do you like, some people love the operational forecast, it's like it's like an adrenaline rush every day. Some people might like the more research oriented model, and maybe those process studies after enough research get, implemented into that model, and there's a feedback loop there, and that's really what they want to do. Or are you interested more in sort of the downstream applications of those model results? So we're across every agency, there's a ton of modeling and analyzing of data. I think it takes a different personality to kind of understand what you want, and that's really what I would be thinking about at this stage.
All right. So I don't know if Michelle, you had any final thoughts on that. If not, we are winding down.
Yeah, that is true. There are a lot of opportunities for data analysis and modeling at QMD as well. So yeah.
Great. So yeah, we are winding down. We had one more audience question, and a really quick answer if one of you wants to kind of jump in on it, but it was about AI and how that might be impacting career opportunities. Should people be worried, or like how they should change their research process, and how can you adapt to those changes? And then that will do some final thoughts, but just a quick rapid answer maybe. or maybe not?
I'll say I don't know yet. You know, for people who are instrument based, it's definitely, you know, that's not going to replace you, certainly in the entirety. You know, I think we're still trying to figure out how to actually be effective with it. I am concerned that, well, that's a different topic, but um, I think I would just be concerned if there's any sort of way in which you offload any of the intellectual development that you do, or yeah, any intellectual development, um, because you're relying on AI too much, because that will impact you later in your career uh, through whether or not you have the like background knowledge to uh, be more effective later on. It's not very coherent, but I hope that makes some sense.
Great. Yeah, I think we're all kind of in this uncertain regime, so I guess we'll just keep going with what we're doing. So last question, and you want to just give a few final thoughts. What is the best piece of advice for someone who wants to work in a government research lab?
I think this is probably a kind of a cop-out answer because I can't think of a better one, but all of these agencies have, you know, these organizational charts broken into gory detail. I would look through one that you're interested in and try to get a better sense of how they're oriented. And a lot of times those pages will have sort of their mission framework and their priorities and their goals. And it is personally, I think, never really a bad idea to understand that. And you can, a lot of them, you know, you can reach out to and get a better understanding of how the lab actually operates. Um, and any of the postdoc opportunities that I think are out there, the first step is, or I think to even have that person open your email is to have a little bit of communication with them. So I think in a world where everything is kind of virtual and you know, via email and other things, you know, having some communication at least, or even a call is always helpful for me. So.
Michelle, do you have any advice?
So, any tips in getting into government research labs? So our labs, we already have like a lot of like set protocols that we have to follow. It's not like as like how we do it in grad school, like more like a research-based lab. Um, so yeah, I don't know if I have like very good advice on that. Sorry.
No, that's great. I think it's important to know that some labs are a little bit more regimented in what they
Yeah, it's
do.
not as heavily research-based. Yeah.
And Gavin, any final thoughts?
Yeah, I would, you know, reiterate what John said, which I think is trying to reach out and get in contact with the people whose interest or whose research you think is interesting, and developing that personal connection, both to, you know, learn something and also get your foot in the door and see whether or not working at a government research lab is actually for you. Because it is, in my experience, quite different from grad school.
Great. So we want to be mindful of everyone's time and our panelists' time. So thank you, John, Michelle, and Gavin, so much for joining us in this hour and kind of giving us your experience at your respective labs. We'd also like to ask if attendees could take a moment to fill out a poll on today's webinar, just so we can maybe improve, or if there are any comments, last thoughts. But yeah, let's give a round of applause to our panelists, and thanks. Have a great Monday.
Thank you. Have a good day.
Thank you, everybody.
Thanks, everyone.